Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving into a survey of context engineering for large language models. It's quite a mouthful, but the implications are huge.
Absolutely, I've been waiting for this. This survey is really exciting because it underscores the importance of context in getting closer to true AGI, in my opinion. It's like we've been building these amazing language models, but they still make these glaring errors that show they don't really understand what they're saying. Context engineering is about fixing that, right?
Well, that's a take on it. I'm not entirely convinced it's fixing anything. It feels more like a band-aid on a deeper problem. The reliance on context, to me, highlights the fundamental lack of understanding inherent in these large language models. They're essentially pattern matching machines, and context is just another pattern they're trying to match.
I think there's truth in both of those perspectives. It's definitely a step, but I'm wondering if it's truly addressing the right problem. To me, the core issue is how these models handle different representations of information, especially spatiotemporal data. Can they really reason about the world in a way that incorporates location, time, and their relationships? Or are they just regurgitating learned associations?
That's a great point. So for our listeners, context engineering, as the survey outlines, is basically about how we provide additional information to LLMs to help them understand the nuances of a query or task. Think about it like this. If you ask an LLM, what's the capital of Washington? It might default to Washington, D.C. But if you provide the context Pacific Northwest, it's much more likely to give you Olympia.
Right, exactly. And the survey goes into all the different techniques for doing this, like prompt engineering, where you carefully craft the input to guide the model, or using external knowledge bases to provide additional information. It's all about giving the model the extra pieces it needs to solve the puzzle. The more pieces we give the model, the better its understanding, and, in turn, the closer we are to AGI.
But isn't that just cheating? I mean, we're spoon-feeding the model information instead of it actually learning to understand the world on its own. Where's the genuine intelligence in that? I think the focus should be shifted to more complex reasoning. The current approach is very brute force.
I see your point, but even humans rely on external context. We don't operate in a vacuum. The question is, how do we integrate that context in a meaningful way? How does the model translate the context into a representation it can actually use to reason? That's where I think the spatiotemporal aspect comes in. If the model can't understand the relationships between objects in space and time, it's always going to be limited.
And the survey touches on that indirectly, I think, when it talks about using knowledge graphs and structured data to provide context. But you're right, it doesn't explicitly address the issue of spatiotemporal reasoning. Maybe that's a direction for future research?
Definitely. Imagine an LLM that can understand not just what happened, but where and when it happened, and how those factors influence the outcome. That would be a huge leap forward. Think about self-driving cars. I mean, you need to model the world around you and how things will change in time and space to navigate around properly.
Okay, but even if you solve the spatiotemporal problem, you're still stuck with the fundamental limitations of deep learning. These models are essentially black boxes. We don't really know why they make the decisions they do. That makes them unreliable and difficult to trust. I think neurosymbolic approaches have a greater potential of understanding because they combine the power of neural networks with symbolic reasoning, right?
I agree that interpretability is crucial, but I'm not convinced that neurosymbolic is the only answer. Maybe there's a way to make deep learning models more transparent, to understand the internal representations they're building. And perhaps the core algorithm needs to coordinate representations in its head. This could also potentially lead to better transparency.
Yeah, and the survey mentions a few techniques for doing that, like attention mechanisms that highlight which parts of the input the model is focusing on. But it's still a far cry from truly understanding the model's reasoning process. It would be cool to see some research on how to visualize and interpret the internal state of these models in a more meaningful way, a direct window into the soul of the model.
I think interpretability is important, sure, but I wouldn't sacrifice performance for it. If a deep learning model can consistently solve complex problems, even if we don't fully understand why, that's still a huge achievement. And besides, we're making progress on interpretability all the time. We're learning how to peek inside the black box.
But at what cost? Are we willing to deploy potentially unreliable AI systems just because they're good at pattern matching? I think we need to prioritize understanding and control, even if it means sacrificing some performance in the short term. The cost could be significant because it may cause harm.
It's a balancing act, definitely. We need to find a way to make these models both powerful and trustworthy. And I think that starts with a better understanding of how they represent the world, especially in terms of space and time. If we can crack that nut, we'll be much closer to AGI.
So let's dig a bit deeper into some specific examples from the survey. One area that I found particularly interesting was the use of context engineering to improve the performance of LLMs on tasks like question answering. They talk about using techniques like retrieval augmented generation, where the model retrieves relevant information from an external knowledge base before answering the question. It's like giving the model access to Wikipedia before it has to answer something.
Yeah, and that's a perfect example of how context engineering can overcome some of the limitations of LLMs. These models are trained on massive amounts of data, but they can't possibly memorize everything. By giving them access to external knowledge, we're essentially giving them the ability to learn on the fly.
But again, isn't that just a workaround? The model still doesn't understand the information it's retrieving. It's just regurgitating facts it found online. Where's the reasoning? Where's the critical thinking? It's all just copied and pasted from a data store.
I think the key is how the model integrates that retrieved information. Does it just blindly repeat what it found? Or does it actually use it to reason about the question and formulate a novel answer? That's where the spatiotemporal aspect comes in again. If the model can understand the relationships between the retrieved information and the context of the question, it can generate a much more insightful and nuanced answer.
Right. Like if you ask it, what are the effects of climate change on coastal communities? It could retrieve information about rising sea levels, increased storm frequency, and economic impacts. But if it can also understand the location of specific coastal communities and their historical vulnerability to storms, it can provide a much more tailored and relevant answer.
Exactly. And the survey also talks about using context engineering to improve the creativity of LLMs. By providing them with specific constraints or prompts, you can guide them to generate more original and imaginative content. It's like giving a musician a specific chord progression to work with.
I find the idea of engineering creativity a bit disturbing. Isn't creativity supposed to be spontaneous and unpredictable? If we're just feeding the model specific inputs to get a desired output, is that really creativity or just sophisticated mimicry?
I think there's a difference between true creativity and random noise. Creativity often involves combining existing ideas in novel ways. By providing the model with a rich context, we're giving it the raw materials it needs to generate those novel combinations. But again, the key is how the model processes those materials. Does it just randomly mix them together, or does it actually understand the relationships between them and create something truly new? How can it spatially understand relationships? Or how can it combine different ideas together?
Think about it like this. You could give an LLM the context of Shakespeare and quantum physics and ask it to write a poem. A purely random combination of those concepts would probably be nonsensical. But if the model can understand the underlying themes and metaphors in both fields, it might be able to create something truly profound and original. I mean, just what would Shakespeare do with modern technology?
And that's where the power of deep learning comes in. These models are incredibly good at identifying patterns and relationships in data. By training them on massive amounts of text and code, we're giving them the ability to understand the nuances of human language and thought. It's only a matter of time before they can truly understand and generate creative content.
I still think you're overestimating the capabilities of deep learning. Pattern matching is not the same as understanding. And creativity is not just about finding novel combinations of existing ideas. It's about breaking free from existing paradigms and coming up with something truly new. I don't see deep learning reaching that level.
I agree that deep learning has its limitations, but I also think it's a valuable tool that we can use to explore the nature of intelligence. The key is to combine it with other approaches, like symbolic reasoning and spatiotemporal modeling, to create a more complete and robust AI system. If we consider them as building blocks to create intelligence, then we can come to a better solution.
So let's talk about some potential future research directions. From my perspective, I'm really interested in exploring the connections between context engineering and neuroscience. How can we use our understanding of the human brain to design more effective context mechanisms for LLMs? I think the brain's ability to integrate vast amounts of information within dynamic internal contexts could be a key inspiration for new ways of building highly intelligent AI.
I'm all about scaling up. I think the most promising direction is to train LLMs on even larger datasets, with even more diverse types of data. We need to explore how non-linguistic data, like images, audio, and video, can be effectively integrated with language models to create richer, more holistic contexts. Give the model more information.
I think we need to take a step back and reevaluate the fundamental assumptions underlying our approach to AI. Instead of just throwing more data at the problem, we need to focus on building more intelligent and interpretable models. I think neurosymbolic approaches offer a promising path forward, combining the strengths of neural networks and symbolic reasoning.
I think the key is to develop algorithms that can handle different coordinate systems and representations in a more flexible and efficient way. We need to understand how the brain translates between different frames of reference and how we can implement those same mechanisms in AI systems. Spatial temporal relations could solve a lot of problems.
That's a great point. Maybe we can look at how the brain uses things like grid cells and place cells to represent spatial information, and then try to adapt those concepts to LLMs. Imagine an LLM that has an internal map of the world and can use that map to reason about spatial relationships. That would be a game changer.
Or maybe we can just keep scaling up the existing models until they spontaneously develop that kind of spatial reasoning ability. I mean, we're already seeing emergent properties in these models that we didn't anticipate. Who knows what they'll be capable of in the future?
I think that's a dangerous approach. Relying on emergent properties is like flying blind. We need to understand the underlying mechanisms that are driving these models, not just hope that they'll magically become intelligent. It's important to consider a combination of different factors.
I agree. We need to be more deliberate about how we design these systems. We need to understand the fundamental principles of intelligence and then use those principles to guide our development efforts. It's a coordinate system.
And that brings us back to the importance of interdisciplinary research. We need neuroscientists, computer scientists, linguists, and philosophers all working together to solve this problem. Because AGI is not just a technical challenge, it's a fundamental question about the nature of intelligence itself.
I'm excited for the future. I mean, we are solving real-world problems with machine learning and AI. AGI is right around the corner, I can feel it. With context engineering, it will only improve.
I remain skeptical, but I'm willing to be proven wrong. I think we need to proceed with caution and prioritize understanding and control over pure performance. It is important to not use AI tools without a full understanding.
I'm optimistic, but I also think we need to be realistic about the challenges ahead. AGI is not going to be easy, but with a combination of hard work, creativity, and interdisciplinary collaboration, I think we can get there. It is a puzzle.
Well, that's all the time we have for today. Thanks for joining us on Cognitive Spirals. We hope you found this discussion informative and thought-provoking. We have an amazing future and many challenges ahead of us.